Hello everyone, welcome to this short video on fundamental theorem of calculus. In this video, we are going to learn how to evaluate definite integral using fundamental theorem of calculus. First, let's look at the statement of the theorem. If y equal to f of x is a continuous function on the interval a through b, and y equal to uppercase f of x is any antiderivative, then the definite integral from a through b of f of x, that's lowercase f of x, with respect to x is equal to uppercase f of b, that is antiderivative of f evaluated at b, minus antiderivative of this lowercase f evaluated at a. So this theorem is called the fundamental theorem of calculus. We use the fundamental theorem of calculus to evaluate most of the definite integrals. Example, evaluate the following definite integrals using the fundamental theorem of calculus. Let's look at the first part. In part A, we have the definite integral from 0 through 3 of 2x over x squared plus 1 quantity squared dx. So if we examine this integral, we see that the denominator of the quantity x squared plus 1 is here within the integral. It's 2x. So if the derivative of some part of the integral is there within that integral, then we use U substitution. So we considered x squared plus 1 as u. So for the first part, let's consider u equal to x squared plus 1. Then if we differentiate du over dx is equal to 2x, which is same as du equal to 2x dx. Now let's make that substitution over here. So if we make that substitution, we'll have, in the denominator, we have x squared plus 1, which is u, and that is squared. So in the denominator, we have u squared, or 1 over u squared. U squared in the denominator is same as 1 over u squared. And then here we have 2x dx. 2x dx is du. We change the integral given in terms of x to a new integral in terms of u. Here we have the limits from 0 to 3. These are the limits for x. Since we are now integrating with respect to u, we need the limits for u. So in order to find the lower u value and upper u value, we plug in the x values into this equation here. So if I plug in x equal to 0, 0 squared plus 1 is 1. So the lower limit is 1. And also the upper limit, if you plug in 3, it will be 3 squared plus 1, which is 10. Now we can easily integrate this function here. Integration of 1 over u squared is negative 1 over u. Negative 1 over u evaluated between 1 and 10. Now we can simplify this using the fundamental theorem of calculus. That is, we plug in the upper limit for u. So if I plug in upper limit for u, it will be negative 1 over 10. We subtract and plug in the lower value. If I plug in lower value 1, it will be 1 over 1, which is 1 with the negative sign in front, that is negative 1. So I'm subtracting a negative 1, which is same as adding 1. Now we have 1 minus 1/10, which is 9 over 10. That is the result for the first part. Now let's look at the second part here. In the second part, we have to integrate sine squared x, cosine x with respect to x, and the limit of integration is from 0 through pi over 2. Again, if we analyze this integral properly, we see that here we have sine squared x. The derivative of sine x is cosine x, which is here within the integral. So we'll be using the U substitution. So in this case, U is equal to sine x. So let me do that here. Let U equal to sine x. This implies du over dx equal to cosine x, or we can write du equal to cosine x dx. du is equal to cosine x dx. Now we can make this substitution over here. So let's see what we get by making that substitution. Integration. So sine x is u, but here the sine is squared, so that's u is squared. U is squared. Then here we have cosine x dx. Cosine x dx is du. We change the integral given in terms of x to a new integral in terms of u. Now we need the values of u over here as the limits of integration. Here we have the limit of integration in terms of x. So in order to get the limit of integration in terms of u, we plug in these limits into this equation. When I plug in 0, u equal to sine 0, which is 0. And when I plug in pi over 2, u equal to sine pi over 2, which is 1. So we change that integral to a simple integral, which is integration from 0 through 1 of u squared du. We can easily evaluate this integral. Integration of u squared is u cubed over 3, evaluated between 0 and 1. Now we can use our fundamental theorem of calculus. That is, we plug in upper limit. So when I plug in 1 for u, it will be 1 cubed over 3, which is 1 over 3. Then minus, if I plug in lower limit, I have to plug in 0 for u. So 0 cubed over 3 is 0. That is equal to 1/3 minus 0 is equal to 1/3. So that is the value of the integral given here in part B. Example, evaluate the following definite integrals using the fundamental theorem of calculus. In part A, we have the definite integral from square root of 3 up to 3 of 6 over 9 plus x squared. So when I look at this integral, it is somewhat similar to this integral, integration of 1 over 1 plus x squared with respect to x. Integration 1 over 1 plus x squared dx is tangent inverse x plus c. So what I'm going to do is I'm going to manipulate this integral and try to write in that form. So let's see how we can do that. This is equal to integration from square root of 3 up to 3, 6 in the numerator. Now I can factor out 9 from the denominator, and it will be 1 plus x squared over 9 dx. That is equal to integration from square root of 3 up to 3. 6 over 9, which is same as 2 over 3, is a constant. I can take that outside the integral. So 2 over 3 outside the integral. In the numerator, I have 1. Now in the denominator, I have 1 plus x squared over 9 is same as 1/3 x quantity squared dx. Now this integral over here is in that form. In place of x, we have 1/3 x squared. So this is the composite function of this function with inside function as 1/3 x. Since the inside function is a linear function, we can directly use this formula and divide the result by the derivative of this inside function. So by doing that, let's see what we get. Let me write here. So we have 2/3, this 2/3. Now when we integrate this, it will be tangent inverse x. So it will be tangent inverse x is 1/3 x divided by the derivative of that inside function. Derivative of 1/3 x is 1/3. And we have to evaluate this between square root of 3 and 3. Evaluate it between square root of 3 and 3, which is equal to, first, 2/3 divided by 1/3 is 2. So it becomes 2 tangent inverse 1/3 x evaluated between square root of 3 and 3. Now we are going to use the fundamental theorem of calculus to evaluate this. So we plug in the upper limit. When we plug in upper limit, it will be 2 tangent inverse 1/3 of 3 is 1. Then minus, if we plug in the lower limit, it will be 2 tangent inverse 1/3 of square root of 3 is same as square root of 3 over 3. That is equal to 2. Tangent inverse 1, the value of tangent inverse 1 is pi over 4 minus 2 times the value of tangent inverse square root of 3 over 3 is pi over 6. So if we simplify this, it is equal to pi over 6. So that is the value of the integral given here in part A. Now we are going to work on part B. In part B, we have the definite integral from 0 up to 1 over 5 of sine inverse 5x dx. So this integral is very similar to the integration of sine inverse x with respect to x. The integration of sine inverse x with respect to x is x sine inverse x minus the square root of 1 minus x squared plus c. The only difference here is the inside function is a linear function. That means we can technically use this formula and then we can divide that by the derivative of inside function. But while using this formula, we have to replace every x by 5x. So meaning of that is this is equal to, in place of x, I'm writing 5x sine inverse 5x minus, it's not minus, actually this is plus, so let me write that there, plus square root of 1 minus x squared. Squared of 5x is 25x squared. We have to divide everything by the derivative of inside function. Derivative of 5x is 5, and we have to evaluate this between 0 and 1/5. We are going to evaluate this using fundamental theorem of calculus. So first we plug in 1/5. So let's see what we get by plugging in 1/5 for x. So if we plug in 1/5 for x, it will be 5 times 1/5, which is 1, times sine inverse. If I plug in 1/5, it will be 5 times 1/5, which is 1. Then plus the square root of 1 minus. If I plug in 1/5, 25 times 1/5 squared is 1 over 25. So 25 times 1 over 25 is 1 divided by 5. Then minus, we'll plug in 0, the lower limit. So 5 times 0 is 0 times sine inverse 0. 5 times 0 is 0. Then plus square root of 1 minus 25 times 0 squared, that is 0, divided by 5. Now here in the first term, 1 minus 1, 0, square root of 0 is 0, so that is 0. Over here, sine inverse 1. The value of sine inverse 1 is pi over 2 times 1, that is pi over 2, divided by 5 is pi over 10. So that is pi over 10 minus, this is 0 because sine inverse 0 is 0, 0 times 0 is 0. Then this one is square root of 1 minus 0 is square root of 1, which is 1 over 5. So we are subtracting 1/5 minus 1/5. So this one, we cannot simplify to a nice number. Instead, we can simplify this using calculator to get the decimal value. So this is approximately equal to 0.1142. So that is the value of the definite integral given here in part B. Example, evaluate the following definite integrals using the fundamental theorem of calculus. Part A, let's work on that first. 0 through 2 e raised to x divided by 1 plus e raised to x dx. Okay, in part A, the definite integral from 0 through 2 of e raised to x divided by 1 plus e raised to x dx. If we look at this integral carefully, we'll see that the derivative of denominator, which is 1 plus e to the x, is in the numerator, e to the x. If the derivative of denominator is in the numerator, then the value of the integral is equal to the natural log of the denominator. Denominator is 1 plus e to the x. 1 plus e to the x. Since the derivative of denominator is in the numerator, the value of the integral is the natural log of absolute value of the denominator, evaluated between 0 and 2 in this case. Evaluated between 0 and 2. Now, if we plug in the upper limit 2, it will be natural log of 1 plus e to the x is always positive, so I don't need to write that absolute value over and over again. If you plug in 2, it will be e squared plus 1 or 1 plus e squared minus, if I plug in 0, it will be natural log of, if I plug in 0, e to the 0 is 1, 1 plus 1 is 2. So it is equal to natural log of 1 plus e squared minus natural log of 2. Since this is the difference of two natural logs, it can be written as natural log of 1 plus e squared divided by 2. So this is how much we can simplify this. And we may want to leave it here, but what we can do is we can simplify this using calculator and get the decimal approximation for this. So this is approximately equal to, if we use our calculator to simplify that, it is equal to 1.434. So that is the value of the integral given here in part A. Now let's work on part B. In part B, we have a definite integral from 0 through 1 of natural log of 5x plus 2 dx. When you look at this problem, it is very similar to the integration of natural log x with respect to x. And the formula for that is x log x minus x plus c. Here, the only difference is this argument of the log is a linear function 5x plus 2. So what we can do is, since this is a composite function with the inside function as a linear function, we can use this formula by replacing all x by 5x plus 2 and dividing the entire thing by the derivative of inside function. So if we do that, it will be equal to, in place of x, we have 5x plus 2, the natural log of 5x plus 2, minus x, that is minus 5x plus 2, everything divided by the derivative of inside function, which is 5, evaluated between 0 and 1. So once we use the formula and we divide by the derivative of inside function, now we can evaluate or simplify this one using the fundamental theorem of calculus. That is, first we plug in the upper limit, subtract and plug in the lower limit. So if I plug in upper limit, let's see what we get. If I plug in 1, 5 times 1 plus 2, the value of 5x plus 2 will be 7. So it will be 7 natural log 7 minus 7 divided by 5. Then minus, now if you plug in 0, 5 times 0 plus 2 is 2. So the value of 5x plus 2 will be 2. It will be 2 natural log of 2 minus 2 divided by 5. Now we have a common denominator of 5. Common denominator of 5. Numerator will be 7 log 7 can be written as log 7 raised to 7. Then minus this one, 2 log 2, it will be log 2 squared, which is same as log 4, natural log 4. And over here we have minus 7. And here when I distribute this negative sign, it will be plus 2. Negative 7 plus 2 is a 5. And it is a negative 5. Minus 5. So it becomes natural log of 7 raised to 7 minus natural log of 4 minus 5 over 5. And if we simplify this using calculator, because we cannot simplify this anymore to get a nicer expression, so all we do is we simplify this to get the decimal approximation of this value, which is equal to 1.4470. So that is the value of the definite integral given here in part B. Example, Evaluate the integral 1 through e of natural log x over x dx using the fundamental theorem of calculus. So let me write that question here. The definite integral from 1 through e of 1 over x times natural log x dx, because log x over x is same as 1 over x times the natural log x dx. By writing like this, I can clearly see that the derivative of the natural log x, which is 1 over x, is also within the integral. So if the derivative is within the integral, we can use the U substitution. So let u equal to natural log x. Let u equal to natural log x. So du over dx will be equal to 1 over x. And if you multiply on both sides by dx, you will get du equal to 1 over x dx. Now we are going to make this substitution over here. So if we make that substitution, let's see what we get. Integration. Natural log x is u, so that is u. And then 1 over x times dx. 1 over x times dx is du. So we change the integral, which is given in terms of x, to a new integral in terms of u. Here, since we are integrating with respect to x, we have the limits for x. But in this one, we are integrating with respect to u, so we need the limits for u. So what we have to do is, we have to plug in the upper and lower value into this equation here and get the limits for u. So if I plug in 1, u equal to natural log 1, which is 0. And then if you plug in e, u will be equal to natural log of e, that is equal to 1. Now we can evaluate this. Integration of u is u squared over 2, evaluated between 0 and 1. And this can be simplified using the fundamental theorem of calculus. That is, we plug in upper limit, subtract and plug in lower limit. If we plug in 1, it will be 1 squared over 2, which is 1 over 2, minus, if you plug in 0, it will be 0 squared over 2, which is 0, that is equal to half. So that is the value of the integral given here.